Hi everybody. Be sure to write down at the top of your paper in your notebook the video number and the title here, which is we're going to be covering properties of inequalities, and we're going to introduce interval notation. Whenever you need to pause during the video, please do so you can take some really good notes. All right, we're going to begin with some inequality vocabulary. This should be familiar to you, but I'm just going to give you a little review so you'll fly through this with me. This symbol, and then we have, of course, this symbol, and then we have these two symbols. So what do they mean? Well, the first two represent greater than. So when I would say x is greater than or 5 is greater than, but then we have that second one, remember, this one here indicates or equal to. Okay, so we do need to keep in mind the difference between those, that this is or equal to. And then we have the similar setup here. These are less than. And then this piece here gives us the or equal to. When it has that underline, it's actually half of an equal sign, and that's why we use it. So that's the or equal to. Now, we're going to go a little bit further than that and talk about when we have inclusive versus exclusive. So these two symbols right here without the equal to part are actually exclusive. Well, the word exclusive means they exclude. So if I were to say x is greater than 4, that excludes the number 4. I'm saying that everything must be bigger than 4, not equal to 4, so it excludes 4, which leaves these two to be inclusive. Which means if I were to say x is greater than or equal to 4, I would be including or inclusive of 4. So this is just a little bit of vocabulary that we're going to be using. I'm going to show you some more vocabulary as we continue. The next thing we're going to talk about are the or statements. These are called compound inequalities, meaning that they're made up of more than one inequality. So we have these simple statements, x is less than -2, or x is greater than or equal to 5. Or statements are unions. A union means things come together. That means that both or all are included. We talk about a union of the states. That means that everybody is involved. Everybody is fair game. It all works. It is a union. It is a unified. We can talk about unions in the workplace. That means everybody is included. No one is left out. So if we're speaking here of x is less than -2 or x is greater than or equal to 5, that means that if I were to say, well, is x equal to -10 a solution? You would say yes, because it satisfies this piece. I could say, well, is x equal to +10 a solution? And we would say, yes, it is, because it satisfies that piece. You see, with a union or an or statement, it only has to satisfy one of those pieces to be considered a solution to the statement. Let's look at this other one here. X is greater than 3 or x is greater than 9. Well, if I choose x equals 4, is it a solution? The answer is yes, it is, because it satisfies this piece. But it actually also does not satisfy that piece. Take my words back. What if I say x is equal to 12? Well, yes, it actually satisfies both pieces. But it doesn't have to satisfy both pieces. It only has to satisfy one of the pieces to be a solution. So we can actually simplify this statement of x is greater than 3 or x is greater than 9. We can simplify that to, well, x is greater than 3. Because once you get to 9, everything's already bigger than 3. It's bigger than 9. So we can actually simplify this or statement down to one single inequality. And statements, they're a little bit different. And statements are intersections. For an intersection, that means that they must overlap. They must be shared. They must work for both pieces. If I say that there's an intersection in the road, you can't just name one road because you need the other road for it to work. So they both, there's a word, it must satisfy both. Well, let's look at this particular one, which I call a between statement because x is between the two values. But I'm going to break it apart. And I'm going to say, well, this says -3 is less than or equal to x, and x is less than or equal to 7. I'm going to rewrite it again. I'm going to flip this entire first piece around and say x has to be greater than or equal to -3, and x must be less than or equal to 7. Well, if it must be greater than or equal to 3 and it must be less than or equal to 7, then it must be between -3 and +7. If you need to hear that again, rewind the video and listen to it. It must be greater than -3 and less than -7. So it's between those two values, and in this case, inclusively between those values. This is an intersection. Let's look at the other intersection here. X must be greater than 5, and it must be greater than 0. Well, wait a minute. Is x equals 1 going to satisfy both of those? It does not satisfy both of those. Does x equal 2 satisfy both of those? No way. So when do numbers first start satisfying both of those statements? Because this right here can be simplified to just x is greater than 5. That's the first time where it is satisfying both being greater than 5 and greater than 0. So sometimes we can simplify these down to a single statement. We're now going to be talking about interval notation, and we're going to be introducing this because it's a different way to write. It's actually simpler than writing using inequalities, but we're going to start with an inequality. For example, I'm going to start with the inequality that x must be greater than -3. This says that all numbers that are greater than -3 would satisfy this statement. That means that all numbers from -3 exclusive to infinity. There's our symbol for infinity. That's what this statement says in English. That's what it means to us when we say it out loud. So we're going to write this using an interval notation. We're going to start with the from and we're going to end at the to. Where does it start? Where does it stop? It starts at -3. It ends at infinity. Let's try another one. X is less than or equal to 5. That means, where does it start? Well, we might want to say that it starts at 5 and it's everything smaller. But the way we count is we count from the smallest number. And the smallest number that I can think of is -infinity. So it goes from -infinity to 5 inclusively. From -infinity, that's the smallest number we can think of, to 5, including it. So how do we write that using an interval? Well, I'm going to start with the -infinity, but this time I'm going to go to 5. So it's the from and to. Now I'm going to use a different bracket here. I'm going to use a square bracket. Why did I use a square bracket? Well, I use a square bracket because I have the inclusive mark. So whenever we have inclusive, we will use the square bracket. Other times we just use the regular parenthesis. So what about infinity? Why don't we use a square bracket on infinity? Aren't we including it? I'm going to let you think about that one. Let's talk about interval notation from a graph. So we haven't actually talked about putting these on graphs, but let's go ahead. So here's a graph. It's actually a number line. It's a one-dimensional graph. It only has left and right, or positive and negative. And if I were to say I want x is greater than 4, then I'll go ahead and put the 0 and a 4 on there. I don't need too many numbers. I'm going to use an open circle to represent exclusive, and then I'm going to shade everything that is greater. So if, let's say, I just started with the graph, how would I write that using interval notation? Well, I'm going to use a soft bracket because I don't want to include the 4. That's indicated by an open circle or by just the greater than symbol. I put the 4, and where is it going? It's going to infinity. Let's look at another graph. What about this one? I'm going to put a solid circle on the -5 and an open circle on the 7, and I'm going to shade in between. So for this one, I'm going to say, well, it starts at -5 and it's including -5, and it goes to 7, but it's not including 7. So this is interval notation that represents this. How would we write that as an inequality? I think it's a good idea if you try that on your own. We're going to try another one. This time, I want you to represent this using interval notation. Well, it might be a good idea to write it using inequality notation first, and that would be x is less than -2, x is greater than or equal to 6. I have to write the word or in between because there certainly is no intersection here. It's definitely a union of two different areas. So I'm going to write this one as coming from -infinity and getting up to -2, but not including it. And then it starts again at +6 and it goes all the way to +infinity. But what do I put in place of the word or? Well, we're going to use this symbol, which represents a union. It's a U for union. One more. I'm going to do an intersection again, which was on the last one, -6 to 4. Let's put open circles on both of those and shade in between. So what does this mean? This means that everything in between those values work. So we can write this as an intersection where x has to be greater than -6 and it must be less than +4. There is your inequality, but interval notation says that we need to go from -6 to +4, and we use the soft brackets. Please review any part of this video that might have been confusing for you or that you need to go back and fill in any areas of your notes. Make sure you try the entrance slip online and we'll practice more in class.